Hey guys, what's up? Hope you're doing great. Nakasha is back with another excited project. So it's called Looper. I just developed a really powerful program uh, which helps you to automate your 3D printer. So it's automate continuous 3D printing. If you are really worried to remove single parts and you need to start from the scratch here, so just stop worrying about that. So I just developed Looper. So basically it's work with all 3D printers. So you don't need to worry about your 3D printer. So first of all, how you can install it and how it's work I will show you in a moment. So just let me show you the video first. Take a look at this video how it's work. So first print is finished. Now it's wait for cool down. So it's wait until bed is 30 and nozzle is 30. So it start ejection method after that. So after ejection it's going to reheat, so it's wait until all nozzle and pad is reheat again. So after reheating it starts your new print again, so all cycle goes all the way like that. So just test it and let's go to screen again. Okay, so now the next part, how you can install it. So first of all, just click a link under description. You come on this page, GitHub. So if you scroll down, there is a installation and usage method. So you must have Node.js installed on your system. After that, just follow this step. It's really easy. So follow these three steps and you are good to go. So here is the first look, how it's look after the installation. So that's here we go. So that's the first look of Looper. So what you need to do, how you can start and how you can automate your 3D printer. So first of all, open your slicer. If you are using Bambu Lab, just open Bambu. It's work with only like Bambu Lab, Pursa, Orca and Slicer. So Creality Slicer. So if you are using Cura or it's not gonna work with Cura right now, but in future update it's just an experimental right now. I already tested with Creality S1 and Kingron KPS3 Pro. So let me show you how you can do it. Just add your any random or 3D model what you want to print here. For me, just use it here for this cylinder. I just add this cylinder here and do all your settings as you like you normally do here. So okay, just slice it, export your G code. So I just name it test loop. Let's name it test loop. I just name it test loop here. Just close your slicer or just leave it open. And now come back to the window of Looper. So what you need to do here next, just click to upload your G code here. So it's really easy, just upload your G code. Okay, we open test loop. So as you can see here, uh, get your all specification of your printer like printer name, size, nozzle temperature, everything they get it by itself. So if you come to ejection method, so we have a three method, but normally I use nozzle one because it's just sweep with extruder. So if you have weak nozzle, so I recommend you can use scraper, but it's little bit advanced. You need to print some parts and attach it with your extruder, and after that just mention the size. If you don't familiar with that, I recommend just go with that. So nozzle one. So first of all we have detachment mode. One is a lift mode and push mode, but lift mode work best for all, so just go with lift mode. If you have like really patchy or ABS material, just go with push mode if you need a hard push here. So second step we have cooldown settings. So as you see in video, so it's finished first print, and it's going to so as you see in video, it's going to finish first print, and then it's go on waiting section. So there is a two type of cooldown settings, one time based. So as you can see here, it's a second one. 300 second means 5 minutes. If you want to increase, just it will wait 5 minutes before pushing the print down. So I recommend go with temperature one. So it's depend on your material and your printer. So if your material like PLA, so it's leave like 30. If we have bed temperature and nozzle temperature is 30, so it can wait. So it can release easily, remove the parts without any headache. So okay. So if you scroll down, now we have a cooldown setting. So cooldown setting, we have a two type of cooldown setting. One, temperature mode, so you can set your nozzle temperature and bed temperature. So your printer can wait to eject that part until it's get to that temperature. So it's depend on your material. Just be experimental. So just check with some lesser time or print. So if we scroll down, we have a cool down setting here. So we have a two type of cool down setting, one temperature and one time based. So what is temperature? So you can adjust your nozzle. So after finishing the print, so it can go this nozzle temperature goes to this temperature and bed temperature goes to this temperature, then they start to eject your 3D print. The other one is a time based. Be experimental, it's depend on your material and printer, how adhesive is your plate, so be experimental. So time based, you can just normally it's like 300 seconds, like a 5 minute. So you can increase it by 1000 seconds, it depend on your print and material. So I go with temperature normally. So it's optional if you want to do that. For viewport, it's only for viewport. Bed configuration 200 200, and this is the really main area. Printer physical limit, make sure you can you know the physical limits of your printer, like a print area of your printer. Like I have a 200 200 and 200. So if you like to have advanced tuning, I don't need that. You need a Z offset, safe height. Just leave it like that. Just be experimental if you want to test. So now here we have the loop count. So loop count, if you go with 10, I recommend just first test with the lower prints, then you can go. So let's say we go with 3 here. Skip skirt after first loop. If you have skirt on your uh, you know what is skirt is. So if you have skirt, so it skips skirt on your second print, so it's just print one time on first print. So next option we have a prime offset. So it's like a, if your printer retract filament after finishing first print, so it's prime again, like insert same amount of filament again to avoid any disturbance. If you have any like problem here, you can adjust it with prime offset in negative value or positive value. Just be experimental. If you don't know what is this, just comment below, I will tell you in detail. So last and final step is ejection mechanics. This is the main step we have. Just make sure you don't do anything wrong here, because it's really there is a chance to damage your print if you do it wrong. So mostly and all printer use forward y minus. So this back mean, so it's eject 3D print in the back of your 3D printer, and the right X plus, it's mean like right. No, don't use this one, because if you have a like what we say gantry of your 3D printer, it's damage that. So make sure you can use forward one. So we have a RAM distance. So let me show you what I mean here. So if you go up and show ejection path here, so that's your 3D print original bed. So now RAM distance is 80 mm. So if your bed size is 200 mm, make sure you just type it 200 mm here. So as you can see here, it start from here and end from there. So it's just ram your 3D print from the machine. So if you have a 3D printer like Bambu Lab or Creality, so if you make it inclined, so it's really work really great. So your printer 3D print automatically fall in the right place you want. Otherwise it's gonna stuck with your 3D printer under the bed plate or somewhere. Otherwise there is one more option like I do here with Kingron. I just attach one plastic sheet or paper sheet under the bed, so when ejection happen 3D print fall on paper or plastic sheet and it's push it down to some bucket. So that's how it works. After that, all finish, all setting you done here. So just click on generate looped G code. So as you can see here, you got the generated loops G code. Just test it with your printer. If you have any problem, just comment below. I will fix it in update. So that's just experimental. I hope you like this video. Subscribe for more tools like this. So thanks for watching. Bye bye.